We all know that the Fortune 500 have been building private clouds for quite some time now. And for the Fortune 50, it's a no-brainer. But how about the rest of us? How about the Fortune 50 million? Why build an OpenStack private cloud if you're a small company? Let me show you why you should. When you want to put your services online, for the most part, you're going to buy these four cloud elements. These are the things that you're going to pay for. And we want to spend as little bit of money as we possibly can to purchase these things. Now, to give you an idea of how much resources of these first four things we would need, here's a few simple examples that are simply a rule of thumb. In no way should we be dogmatic that it's always going to be this. But 1 core and 1 gig of RAM might be a simple web server. 2 cores and 4 gigs for a database. Maybe 4 cores and 16 gigs to create a Hadoop node. And then 8 cores or 32 gigs for a high performance compute. And you can definitely go bigger than this. So every time that you increase these first two items here, the cost goes up. The cost doesn't drive up nearly as much when you add traditional ephemeral storage and networking. Actually, those items 3 and 4 are really reasonable. Let's take a look at what the costs really are. An example of an Amazon M4.2X large, which would have those 8 cores, 32 gigs of memory, only 20 gigs of ephemeral storage, and 500 gigs of actual networking throughput that's going to be required. Let's take a look at what it costs. So items 1 and 2 are 43 cents an hour. Now contrast that with the ephemeral storage and the networking, which is based on a month, and it's 10 cents a month for the storage and $5 to move 500 gig of data. Wow, I wonder if I'm going to move 2 terabytes. Well, then it would be $20 a month. It turns out that, as I told you, these items 3 and 4, as long as you're using ephemeral storage and classic networking, they're not particularly expensive. So let's add it all up, shall we? If there's 8,760 hours in a year, then let's multiply that times 43 cents and we'll come up with $3,767. Add in the rather trivial cost for networking and storage, and we're going to have to pony up $3,828 a year for the M4 2X large. And let's divide by 12 and just say 320 a month. Now it's actually 319. I rounded it up to 320. Makes it easy to remember. Here is a $64,456 cloud. Now, the cloud hardware, that's what actually provides the services, are those 6 compute nodes. And they're beefy machines, and the price sort of says that. The cloud controller, or the control node, actually is what launches, creates, and deletes the virtual machines. So if you take a look at a compute node, we can get a pretty quick idea as to how powerful this is. $829 for a bare bones server, which has 24 RAM stick positions, of which you'll see we're going to fill 16 of them. So we add, for $4,400, we add 512 gig of RAM, or a half a terabyte of RAM. $3,694 to buy 2 Xeon E5 2680 processors running at 2.5 gigahertz. That will create, to the operating system, because of hyperthreading, it will appear as 48 cores. I use a multiplier of that 2.5 so that I can create 120 virtual cores. That way I can say a virtual core is guaranteed to deliver at least 1 gigahertz of processing if all the cores are running flat out. Of course, I need ephemeral storage, and let's go with solid state drive. So these are going to be two 2 terabyte solid state drives, or 4 terabytes of RAID 0. So this is screaming fast storage. That would actually be really expensive in the Amazon picture. I'm not going to run up the Amazon bill. When you see what the numbers are here in a moment, you'll see I don't have to. So there you have it, the 6 compute nodes, roughly $10,000 each, and a controller totaling $64,456. Now, do you remember that M42X large that we were talking about? That cloud that I've just shown you is 90 of them. Now, if that Amazon M4 2X large is $320, and I can purchase the example of our cloud, this Alta 3 cloud, for $64,456 in capital expenditure, then I need to compare these two numbers and see if there's a payback. So all I need to do is take 90 times that 320 months, and I'm going to come up with $28,800 a month. And I got to tell you, that starts looking a lot like our Amazon bill. And in our experience, as our success grew, Amazon bill started out really reasonable. And in very short period of time, starting to see these exorbitant numbers. And it was clear to me after a little bit more math, this is going to be $345,600 a year. And I'm thinking, I'm pretty sure I could build a cloud. And I have to do the same work to load software, whether I'm loading it on Amazon or whether I'm loading it on my own cloud. So none of this just made sense to me. So with a little bit of math, calculating that Amazon bill is $28,800 a month, and this one-time cost of a Alta 3 cloud is $64,456, I could calculate quickly. Looks like a 2.24 month payback, or in other words, 68-day return on investment. That means that I could completely throw this cloud away and rebuild it every 68 days. This is crazy. In fact, I doubled down. I checked the math 3 or 4 times before we built our first one, and the math consistently checked out. Well, I can tell you that when we built this cloud, we were much more careful in our purchasing. We didn't spend that much. We spent less than $50,000 actually. And we wound up with a cloud that has just been wonderful for us. So the plan, of course, is to replace the private cloud every so often. In fact, every 4 years. So you'll see here we build cloud one, and then 4 years later, we'll rebuild that cloud. And then what we do is we stagger every 2 years. If we're going to run two clouds, the second cloud will be built on the second year, and then it would rebuild 4 years after that. So what it really looks, if you just look at as pure expense, this is about a $32,200 a year expense that we're going to have to just build a cloud. Now contrast that $257,824 to the Amazon $2,764,800 bill. And it just affirmed everything that I was thinking, that I can build a private cloud for way less than I can rent one. Furthermore, I'm going to have to hire people and pay them to load software onto either one of these, no matter what. But I'm going to tell you right now, what we found out was that we can load the software onto our own cloud massively faster than we can if we went actually on the Amazon side of things. That was just some icing on the cake that we learned later. Now, I know what you're thinking. How about the data center space required for this? Cooling, electrical power costs, power backup, networking, software licensing. Those things are actually trivial, as it turns out. I have empirical evidence. I'll show you that. But I gotta grant you that that item number 7 is a very big deal. The staffing and the skills required to do this. That's essential that you have that. Now, a large amount of the staffing and skills are required to put the software on an Amazon cloud. We've found actually that deploying software on an Amazon cloud is actually a little bit more difficult than deploying it on our own cloud. But let's take a look at these first 6 items first. Regarding item number 1, which is the data center space requirements, right here is a Callaway driver. This is a golf club. So if you know how big a golf club is, you're going to notice that our cloud is not very big. In fact, the cloud that we were talking about is this part right here. These extra components that you see are an Ansible server. We use Ansible to configure the cloud, and then 2 gigaspeed routers that we use to actually connect to the network. Now, regarding item number 2, that's the actual cooling requirements. These are air-cooled servers that we're using. So in Fahrenheit, that would be 60 to 80 degrees, or centigrade or Celsius, 15 to 26 C. So item number 3 was the power costs. What's that? So we do run a load management system. So a quick reference shows 9.6 amps is the constant pull. Now we're running the cloud flat out all the time. So this is the power requirement. So I simply multiply by the line voltage to come up with 1176 watts. Take that number down, convert it to kilowatts by sliding the decimal point over 3 times, and then multiply by 24 hours a day, 365 days a year, and we wind up pulling 10.3 megawatts of power every year. So our bill comes up $120 a month roughly. So in the scheme of things, the electrical costs are fairly insignificant. Now, it has nothing to do with the cloud, but I can already hear people saying, but you're not being green. Well, yes, we are. Last year we ran this solar array. It was absolutely amazing. Went ahead, deployed another 2. I can tell you, first of all, solar works. It's been an absolute riot to try it out. It's producing about $200 a month in actual electrical expense. Or if you look at it, we're pushing back a little more power than our cloud is pulling. So I actually pulled up a report to take a look at how much power we pushed back last year, and we pushed back 12.8 megawatts, which is less than we pulled in. Now, right around the August time frame, after we spent this period of time, and I went through that phase as, wow, this actually works. We doubled the array. I showed you those extra arrays that we placed in. So I'm expecting next year generations somewhere like this. So I'm going to guess somewhere around 20 megawatts next year is what we're going to consume. But I know for a fact that the cloud that I've just showed you is going to pull 10.3 megawatts, which is less than that. Now, what if the sun doesn't shine? And what if the line voltage goes off? Then we're in a problem, right? Well, actually, no. A backup generator has been here for a while. That's $10,000 one-time expense. We expect that to last many years. Use it one time, and it got us through about a 5-hour power outage. It generates 20 kilowatts, and we already said that our cloud only requires 1 kilowatt. So the extra 19 kilowatts that we get actually keeps the rest of the office running. While it's nice to know that if I would be running my services up in Amazon and the lights go out, that all keeps running, it never made sense to me that that's great. Okay, my services are running up as Amazon, but all my lights are out. My phone systems are down. This is not good. And it turns out that a backup power system to pick up all of the essentials wasn't a deal breaker, and it was very reasonable. And looking at the amount of savings that we're getting using a private cloud versus the public one, this, in my opinion, was just a wonderful bonus. So the way that all of this hooks up, our line power comes in like this, and then the first thing it will do is actually hit an automatic power transfer switch. So our cloud has about a 20-minute battery backup in the bottom of it, and the automatic power transfer switch, under normal conditions, would be switched over to this side, actually bringing line power right into the office. Merging in with the office, of course, is solar, so that if the solar is pushing harder than the office is consuming, which is definitely the case when the sun's shining, then we're pushing power back onto the grid and we spin that meter backwards. It's an absolute hoot to watch it happen. If you haven't tried it, I suggest you give it a whirl. It's a blast to watch that happen. So suppose that we do lose line power, then the automatic transfer switch is going to connect to the generator right here. So that little switch just disconnects there and we wind up connecting the generator. And of course, the office is running. During that period of switching, all of our compute is actually running on battery backup. So we never really feel the change, just the lights just come back on a few minutes later and everything just keeps on working. So how about networking? That was item 5 on our list. The way we're handling that is with gigaspeed passive optical networking. I have 2 links that are running, a total of $300 a month. So I have a 500 meg or a half a gigabit per second coming in. And on a separate panel, we have a 100 megabit backup. Now a phone call to the phone company can increase that number if I need to. But if things get really bad and outage, network outage is significant on our primary, at least I have connectivity to the network, and we may have to spin some things up to Amazon for the moment. Although I doubt it, I'm expecting the phone company to make good on their promise and increase that number if we need it. But we could limp by on 100 meg if we had to for a while. We just wouldn't like that. Now, regarding software licensing, that was item 6 on the list. I just want to make sure that we're clear on this. We don't do this. We deploy from source. OpenStack is free, so I don't really want to rent it. But if you want to deploy OpenStack, for instance, from Red Hat, then you're going to figure on somewhere around $2,500 a socket. And we said there's 2 Xeon processors in here, so that's where the $5,000 comes from. And if you're going to have 6 compute nodes, then you're going to pony up $30,000 a year, each and every year, nonstop. I don't believe in this $30,000 a year rental of free software. We don't do it, but if you're going to purchase, if you're going to basically buy into like a Red Hat type thing and get the support that comes along with it, that is the price. You would have to add that in if you're going to go that way. So what are the conclusions then regarding building a private OpenStack cloud? Our experience is that the return on investment is insanely good. We have already paid for the cloud over and over again. Every 2 months, I look back and think, wow, I just paid for another cloud. So what this allows us to do then is this, well, then we'll just run 2 geo-redundant private clouds. And if we would knock a cloud offline, which we haven't yet, that has not yet happened, but if we would have a backup that would kick in. We are planning on rebuilding the cloud every 4 years, and that's just a $32,000 expense that we're just going to budget every year. So the 2-year spacing on the cloud rebuilds makes sense, but I don't know that you have to do it every 2 years. You could probably stretch that out a little bit farther if you'd want to. Now, that's the return on investment. That's the pure money aspect of it. What happened to the Alta 3 staff was amazing. What happened was that we developed crazy, powerful tech skills. It just became the norm. And what happened was we can just build whatever we want when we want it. And another issue that I have as the owner of the company, some of my most powerful developers had a tendency to leave machines run, and really big machines, over the weekend, all weekend long, or during the week, overnight, and things like that. And I just felt like I was chasing the kids to turn the lights out. And I really don't like taking an adversarial relationship with really smart people over something as trivial as, would you please turn these really expensive machines off? Why did you leave it run overnight? That's not an issue with private cloud. They can run it as long as they want to. But obviously, if they max out the cloud, it's no issue really. Just turn off the machines that you obviously left running. While maybe that runs up the electric bill to some degree, it's nothing that I can do math on it turns anything reasonable. Now, this is not to say that we don't use Amazon. We certainly do. We have about a $50 a month Amazon bill, which is way better than that $30,000 one. But we use it when we're backing stuff up. So one reason would be that we would want to rebuild our cloud. And when we do, we take the entire cloud down. Guys, listen to me. This may surprise you, but when we take our cloud down, we take it all down. Every single web presence, everything, all our database servers, all of our inverse proxies, firewalls, everything is running on that cloud that's all virtual. And we put it back with an Ansible playbook. What it has done is it's made our staff absolutely fearless because we can tear the entire cloud down. And the last time we did it 2 weeks ago, just for sport, I was drinking coffee and I wasn't uptight. And it went in actually into Sunday morning a little bit, because we were doing some cool things. I said, oh, we'll just get it tomorrow. And of course, everything finished up just fine. So what happened to our web presence? Well, we put the essential stuff out on Amazon, and over the weekend, we're not particularly busy, so that wasn't a big deal for us. That was like $10 or $50 maybe to run that service over the weekend. And that's what Amazon is for, is when you want that kind of backup or extremely short bursts of extra compute. Anyhow, when we finished the cloud rebuild, networking was faster. There were several other items that were faster. And the reason that we were so fearless about this is because we know that all of our playbooks work. And that if we had to, we'd just put it back the way it was. So truly wonderful in that regard, the ability to completely rebuild an OpenStack cloud. I'm not saying that you have to do it that way by all means. I'm just saying that that kind of behavior is suddenly possible, and never in an IT organization could we do something that big so fearlessly. Now, that item number 7, that's actually the big deal, staffing and skills. And that's the area that actually is our business. So if you check out alta3.com, we're a training company. We teach people cloud services as well as a host of a whole bunch of other things. And while we could build clouds and we built them for our Fortune 500 friends, building one for ourselves was a wonderful treat. I'm just absolutely thrilled at the payback. So if you're a small company like us and you're thinking, I'm too small for a cloud, you might want to rethink that process. But you will need the skills. So here are the core skills that we are pretty dogmatic about. This is what it takes to do what we did. So a 5-day OpenStack administrator class teaches you how to run OpenStack. So if someone else would have installed OpenStack for you, then this is the course that will teach you how to run it. Now that you know how to run it, you need the skills. This is the rudimentary skills to put the cloud there in the first place and then to install the services on the cloud. You see, you can build an OpenStack cloud, but then you want to load web servers and inverse proxies and load balancers and firewall services, and the list goes on, right? You want to deploy that stuff on the cloud. These are the skills that are developed to do that. And in these skills, we show you that there's a lot of code on GitHub that you can just go ahead and bring in. Why write your own when tweaking code that's out there and free would get the job done? Now, of course, you want to build your own cloud. Let's say that this is just too good to resist and you're going to do this. Then the OpenStack deployment workshop is for you. Now that's 5 days where you will exercise your Ansible skills big time. And of course you have to know how to drive the cloud. So when you come into the OpenStack deployment workshop, you have a certified OpenStack administrator certification or the equivalent, and you have strong Ansible skills, at least what we would have given you in 3 days and some practice. Then after those 5 days, you will know how to deploy a cloud like we've done. Then the rubber hits the road and you say, okay, I'm actually going to deploy it. Well, we've been in the training business long enough to know that when you're in the class and you're in that controlled lab environment, everything's just going fine. The labs are bulletproof and you think like you're just impervious to any harm. And then you're thinking, well, okay, let's go ahead and deploy it. And if you're at that stage and you're concerned you need a little bit of help, we're happy to lend a hand there as well. 5 days of consulting, which is probably 3 days more than necessary, would actually be enough time to build the cloud as I've just shown you. And by the way, I really don't care if it's 6 compute nodes or 20 compute nodes, whatever, in fact, whatever fits in a rack. Ansible doesn't care. When Ansible builds a cloud, it builds all the compute nodes at one time. So it doesn't really matter if there's 1 or 2 or if there's 80 of them. Ansible will actually set them all up for you. And then, of course, the controller. If you're running that many compute nodes, you will run the controllers in high availability. Now, for those of you, probably more of our Fortune 500 persuasion, who are actually interested in going beyond that, then software-defined networking becomes a very big deal to you. This is actually taking some of the tricks that actually were first tested in cloud and deploying out into actually the hardware network as well. So here's a 5-day class on SDN that winds up being a deep dive into OpenStack Neutron, plus additional skills that you would need to actually roll SDN into real hardware-based routing and switching as well. Now, the first example here of SDN is an architectural class. The network automation using Python and Ansible is a how-to class. So this particular class actually will show you how to make all that previous stuff happen, and it's 5 days. There's no requirement to take the SDN class and then take the automation class. These can be in either order. But if you're looking for a really serious return on investment, like we spoke about here, this is the training required. It's actually a skills issue. You put these kind of skills in your staff, and now you have them on top of your cloud, not somebody else's. They're going to get good at running your cloud. In fact, they will become amazing. And incidentally, in this particular deployment practice right here, all of the playbooks that we've written are provided, and we show you how to use them. And then if you want, we can come on site and actually help you build it. If you'd like to do that, if you just want to work that over the phone, that's fine as well. Well, there you go. I hope you take me up on this and decide that it's time for you to build your own cloud. Best wishes to you.